Good day, everyone. Okay, in this video, I want to discuss one sample problem in the chapter Momentum and Impulse. Okay, so we're in this particular sample, we are going to be working with two dimensions, right? So let's look into it. A ball of mass 0.3 glances off of a wall as shown in the diagram. The ball approaches at 12 meters per second, right? It goes in 12 meters per second. I'm just going to write that down. 12 meters per second at an angle of 35 degrees and leaves at 10 meters per second at 20 degrees. The collision lasts for 12 milliseconds. What are the components of the impulse experienced by the ball, and what are the components of the average force acting on the ball? Okay, so let's look at the first part of the question, which is what are the components of the impulse experienced by the ball? Okay, so may I just remind you that impulse is just a measure of the change in momentum. So when we talk about the change of any variable, we will always talk about a before and after situation. So it would be very useful for us to consider a before scene, right? So here we have this part, right? Before the collision, zoomed in, and I've also shown you the x and y components of the original momentum or the initial momentum. So we can break it down into py and px, right? So let's do it with y first. So py, this is before scene, yeah? So py would equal to our p, right, sine theta. And we can expand, or we can substitute this p with mv. So let's use our initial, so it's going to be mu, right, sine theta. So our py is going to be the 0.3 multiplied with 12 meters per second, and then sine 35 degrees. Okay, now I need to remind you that when we look at these problems, we have to set the directions, right? So let's assume going to the right is the positive x direction and going up is the positive y direction. If that is the case, then our u here, right, is going to be in the negative y direction. So we will have to put a negative sign in front, you know, a negative sign, no, yeah, and then we have to multiply the whole thing with a negative 1 as well, simply because it's going downwards and not upwards. Okay, so then we will have negative 2.06 4875. I'm just going to take the 6 decimal points, and then we can work out px as well. Okay, don't forget your units, which is Newton seconds. I'll work again with the x component, which is going to be p cos theta, right? And as we can see, it's going to the right side, so it's going to be in the positive x direction, so we can just leave it positive. So it's going to be mu cos theta, and then our px is going to be 0.3 multiplied by 12, and then cos 35 degrees. And that's going to be 2.948 2.9489477 Newton second. Okay, so we have our initial y component, y momentum component, y component for momentum, and we have the initial x component of momentum. Okay, let's work with the after. All right, so here's the after. Again, we can have py equals to p. Again, it's going upwards, so it's going to be positive, right? So p sine phi, and that's going to be mv sine 20 degrees. So py is going to be mv, so that's 0.3 multiplied with 10, and then sine 20 degrees, and that's going to give us 1.02 6060, so Newton seconds. And we can do the same with x, which is p cos phi. That's going to be mv cos 20 degrees. And then our px will yield, again, you use the same values as on top, and we will get 2.81. 9078 Newton second. Okay, so now we have two values, right? We have the before and after. Before, after, before, after. Alright? So, okay. So in order for you to calculate impulse, you have to know the difference. So we will match the y component before with the y component after, the x component before and the x component after. So at least the way I see it, the easiest way to do this is actually using a table. Okay, so these are the values that you have, and all you need to do now is just take the difference, right? You take the difference between the x components and you take the difference between the y components. Okay, so the x components will be I'm just gonna write it down here, 2.819078 minus 2.948947, and that is going to yield us a value of negative 0.129392, right? And that's going to be in Newton second, which is here anyway. And then the second part as well, you can take 1.026060 minus negative, sorry, 2.064875. Okay, you take the difference, and the difference is going to be 3.090935, and this difference is going to be your impulse. So these are the components that they were talking about. This is the x component, and this is going to be the y component. All right. So that is the difference. I mean, that is the answer, basically. That is the difference in momentum, which tells us it's the impulse, because impulse is defined by the difference in momentum. All right. Okay. So we're done here. That's the answer. This is the x direction, and this is in the y direction. Let's move on to the next question, where they're asking what are the components of the average force acting on the ball. So just to remind you that force, right, times delta t, which is the collision time, right, is going to be equal to your impulse, which is what we label J, right, which is your impulse. So we can fairly simply rearrange this equation to get that our force is going to be our J, our impulse, over our delta t. Delta t being the collision time. Okay? So we can always just break this down into, again, x and y component. Our fx component is going to be our Jx component over delta t, and that is going to be, let's see, x component, which is negative 0.129392 over 12 times 10 power of negative 3, right? And we will yield negative 10.7827 Newton. That is in the x direction. So 0.129392, 0.129392. Okay, it's fine. And then we can do the same thing with Fy, right? Because, you know, it's the same equation, it's just in different components. So we can write down that Fy equals to Jy over delta t, and then we take the value from the previous slide, 3.090935. So again, 3.090935, and then we divide with the same collision time, right? So 12 times 10 power of negative 3, and that will yield you an answer of 257.5779 Newton. So those are the components of the average force acting on the ball. Okay, so that's our answer. Okay, so that's the end of this question, and that's also the end of this video. I'll see you in the next video. Thank you very much.